Hi, is this the magnetic field crushing this coil inward or ripping it apart outward? Let's find out in this question. So, we are giving a scenario that this is a coil which is placed in a uniform magnetic field. Now, when we say the uniform magnetic field going into the page, so actually it means that all of the field is going in a negative z direction if you call it negative z axis. So, this is a direction of the magnetic field. So, right now, the maximum flux is produced because all the lines are perpendicular to the surface. So and secondly, this coil is carrying a current which is a clockwise. So clockwise means that this current is flowing in this direction like this. So we know that whenever a coil or a wire carries the current in a magnetic field, and if it is placed perpendicular, then there is always a maximum force exerted by the magnetic field. And why is that? Please understand that when you place a coil or a wire in a magnetic field, so actually the two fields interact. What two fields? The one field that is called external field, which is going into the plane, and secondly, the field that is produced by the coil itself. So if these two fields are interacting and they are opposing each other, they are canceling out each other, that determines the direction. So and we use obviously the Fleming left hand rule to find the direction. So this is the Fleming rule. So according to this rule, this arrow is always represent the magnetic force. This is the magnetic field strength, and this is the current. So FPI rule, and the angle between all of them is 90 degrees. So we will apply this rule on this coil, and exactly if the current is flowing in this direction, then what is a force? So you can align FPI. So you can align this finger, this is my left hand, this finger is representing the direction of current, this is representing the direction of magnetic field which is going into the plane, and you can see my thumb is pointing downward, which is clearly showing us that the answer should be the option D, which means that the force exerted on this segment of the coil is downward. But our video is not ending here because interesting part is coming. So I will show you more conceptually that why it is downward. But first of all, according to the Fleming rule, you can see that the current flowing in that part of is this is representing the current's direction, and this represents the direction of the magnetic field strength. So the force is perpendicular to the both of them. So this is the force. Now, please come on this part where I'm going to show you the direction of the current in this coil, which is going in this direction. So imagine it is a piece of wire which carries a current to the left, my left. Okay. So if I apply the right hand grip rule, pointing my thumb in the direction of current, so I see the curling fingers are showing the direction of current. So on the upper side of the wire, the fingers are going into the plane, and on the lower side, the fingers are coming out of the plane. So I can draw here the magnetic field of the wire like this: cross, 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 cross on the upper side, and dots on the lower side, which represents the magnetic field of the wire. Now, what is the direction of the external field? Dear students, external field's direction is into the plane at all the positions. So don't you think there's a one area where the two fields are opposing each other, they are canceling out each other, weakening each other, right? And that is easy to guess, obviously, on the lower part, where the one field is going into the plane and the one field is coming out of the plane, and both are canceling out each other, and hence you have a strong field on the upper part and the weak field relatively this part. That's why the force is exerted downward. Okay, just last but not least, what will be what will happen to the coil? Well, if we draw the free body diagram of a coil, nothing will happen to the coil, because if I represent the whole coil as a dot, means an object, so the force on this part is upward because current is going in opposite direction. then this one. So if the force is applied downward, then on this side the force will be applied upward, and equal amount of force. So I can draw this arrow, and on the lower part this arrow is down. On the right hand side, I mean this part, the you can draw like this: FBI. So current is going down, so the force is exerted in this direction on this part, and on the other part, this part, the force will be obviously in opposite direction. So these are all forces are in same magnitude and in opposite direction. So hence the F net is 0. So neither this coil is crushing inward nor it is ripping it apart outward. So nothing is happening.